Let's simplify this algebraic expression step by step. We'll group like terms and combine their coefficients. First, let's identify the different types of terms we have. We have terms with x squared y, terms with xy squared, and terms with xy. Let's start by combining the x squared y terms. We have 11 over 2 plus 1 over 15. To add these fractions, we need a common denominator of 30. Next, let's combine the xy squared terms. We have negative 9 over 4 minus 1 over 14. To add these fractions, we need a common denominator of 28. Finally, let's combine the xy terms. We have 1 over 4 plus 1 over 2. These are easier to add with a common denominator of 4. Now, we can write our simplified expression. The final answer is 167 over 30x squared, y minus 65 over 28x y squared plus 3 over 4xy. To verify our answer, we can check that we combined all like terms, all fractions are in their simplest form, and we maintained all signs throughout our calculations. And that's how we simplify this algebraic expression. Thank you for watching. The problem involving finding the volume of a cuboid with algebraic dimensions. We need to find the volume of a cuboid with dimensions 3a squared b squared, 2ab, and a squared b cubed. Let's visualize this cuboid. Here's our three-dimensional cuboid. The length is 3a squared b squared, the width is 2ab, and the height is a squared b cubed. To find the volume of a cuboid, we multiply its length, width, and height together. So, volume equals length times width times height. Let's substitute our dimensions into the formula. Volume equals 3a squared b squared times 2ab times a squared b cubed. Let's solve this step by step. First, let's multiply the numerical coefficients. 3 times 2 equals 6. Now let's combine like terms. For the variable a, we have a squared times a squared, which gives us a to the 5th power. For b, we have b squared times b cubed, which gives us b to the 6th power. Therefore, the volume of the cuboid is 6a to the 5th power b to the 6th power. Let's box our final answer. To verify our answer makes sense, let's check the units. The volume should be in cubic units, and if we count the powers of our variables, 5 plus 6 equals 11, divided by 3 equals about 3.7, which is reasonable for a three-dimensional shape. And that's how we find the volume of a cuboid with algebraic dimensions. The key is to carefully multiply the three dimensions together and combine like terms. Remember to always check if your answer makes sense dimensionally. Let's solve this value-added tax problem step by step. Shruti bought a set of cosmetic items for 345 rupees, including 15% value-added tax, and a purse for 110 rupees, including 10% value-added tax. We need to find what percent VAT was charged on the whole transaction. Let's start by finding the actual VAT amount paid on the cosmetic items. For the cosmetics, the total amount, including VAT, is 345 rupees. To find the VAT amount, we first need to find the base price. If we call the base price x, then x plus 15% of x equals 345. Simplifying this equation, we get 1.15x equals 345. Therefore, the base price x equals 300 rupees. This means the VAT amount for cosmetics is 45 rupees. Now, let's calculate the VAT amount for the purse. The total amount, including VAT, is 110 rupees. Using the same method, if we call the base price y, then y plus 10% of y equals 110. Simplifying, we get 1.1 y equals 110. Therefore, the base price y equals 100 rupees. This means the VAT amount for the purse is 10 rupees. Now, we can find the total VAT percentage for the entire transaction. The total VAT paid is 45 plus 10, which equals 55 rupees. The total base price is 300 plus 100, which equals 400 rupees. To find the VAT percentage, we divide the total VAT by the base price and multiply by 100. So, 55 divided by 400 multiplied by 100 equals 13.75%. Therefore, the effective VAT rate charged on the whole transaction is 13.75%. This makes sense because most of the purchase value came from the cosmetics, which had a higher VAT rate of 15%, while the purse with a lower VAT rate of 10% made up a smaller portion of the total purchase. Let's simplify this algebraic expression step by step. We have 11 halves x squared y minus 9 fourths xy squared plus 1 fourth xy minus 1 14th y squared x plus 1 15th yx squared plus 1 half xy. To simplify this expression, let's first group like terms. We'll group terms with x squared y together, terms with xy squared together, and terms with x, y together. Let's simplify each group one at a time. First, let's look at the x squared y terms. We have 11 halves x squared, y plus 1 15th, yx squared. To add these fractions, we need a common denominator of 30. Next, let's look at the xy squared terms. We have negative 9 fourths xy squared minus 1 14th y squared x. Again, we'll need a common denominator, this time of 28. Finally, let's combine the xy terms. We have 1 fourth x y plus 1 half xy. These can be added with a common denominator of 4. Now that we've simplified each group, let's write our final answer. The expression simplifies to 167 30ths x squared, y minus 65 28ths x, y squared plus 3 fourths xy. Let's verify our answer by checking that. 1, we've combined all like terms. 2, each fraction is in its simplest form. And 3, we've maintained all original terms in our simplified expression. And that's our final simplified expression. Remember, when simplifying algebraic expressions, always group like terms first, then combine them using common denominators when working with fractions. Solve some problems involving value-added tax or VAT and sales tax. These are taxes added to the original price of items. Let's start with the first problem. Rakesh bought a mixer grinder for 3,300 rupees, including 10% VAT. We need to find the price before VAT. Let's solve this step by step. To find the original price, we can use this formula. Original price plus VAT equals final price. If the VAT rate is 10%, then the VAT amount is 10% of the original price. So, original price plus 10% of original price equals 3,300. This means 1.1 times original price equals 3,300. Therefore, the original price is 3,000 rupees. For the second problem, a sewing machine costs 1,500 rupees with a 6% sales tax. We need to find the total amount to pay. Let's solve this. First, calculate the sales tax amount. 6% of 1,500. That's 90 rupees. Add this to the original price. 1,500 plus 90 equals 1,590 rupees. For the third problem, a LED TV costs 13,440 rupees inclusive of VAT. The original cost is 12,000 rupees. We need to find the VAT rate. Let's solve this step by step. First, find the VAT amount by subtracting the original price from the final price. 13,440 minus 12,000 equals 1,440. To find the VAT rate as a percentage, divide the VAT amount by the original price and multiply by 100. That's 1,440 divided by 12,000 times 100, which equals 12%. Finally, for the fourth problem, a refrigerator costs 13,750 rupees, including 10% VAT. We need to find the original cost. This is similar to our first problem. We know that the final price is 1.1 times the original price. So 13,750 equals 1.1 times the original price. Therefore, the original price is 12,500 rupees. Let's summarize the key points for solving VAT and sales tax problems. To find original price when given final price and VAT rate, divide final price by 1 plus VAT rate as a decimal. To find total amount when given original price and tax rate, add the tax amount to original price. To find VAT rate, divide VAT amount by original price and multiply by 100. Today we'll solve some grade 8 algebraic expression problems. Let's go through them one by one. Question 1. Find the coefficient of x in the expression x, y, z plus 7, y squared z minus 8, r. Let's solve this step by step. In the term x, y, z, the coefficient of x is 1, since if no number is written, the coefficient is understood to be 1. In the other terms, x doesn't appear at all. Therefore, the coefficient of x in this expression is 1. Question 2. Identify the following expression based on its terms x, y plus yx. Let's analyze this. The first term is xy, and the second term is yx. Due to the commutative property of multiplication, xy equals yx. Therefore, these are like terms. We can combine them xy plus yx equals 2xy. This expression contains like terms that can be combined. Question 3. Find the perimeter of a triangle whose sides in terms of x are 5x squared minus x plus 8, x cubed minus x, and x squared minus 4x plus 10. To find the perimeter, we need to add all three sides. Let's add them term by term. For x cubed terms, we have only one term x cubed. For x squared terms, we have 5x squared plus x squared, which is 6x squared. For x terms, we have negative x minus 4x, which is negative 6x. For constants, we have 8 plus 0 plus 10, which is 18. Therefore, the perimeter is x cubed plus 6x squared minus 6x plus 18. Question 4. Find the continued product of x minus 1, 3x cubed minus 1, 2x squared plus 3, 9x to the 12th plus 4, and x to the 20th. For this problem, we need to find the degree of the resulting polynomial. The first factor has degree 1, the second has degree 3, the third has degree 2, the fourth has degree 12, and the fifth has degree 20. When we multiply polynomials, we add their degrees. Therefore, the degree of the final product will be 1 plus 3 plus 2 plus 12 plus 20, which equals 38. So the final product will be a polynomial of degree 38. And that concludes our solutions to these algebraic expression problems. Remember to always solve step by step and pay attention to the terms and their degrees.